There's not too many things you can count on in life, but gravity is one of them. When you lose your balance and fall, that's gravity at work. Over the past 10 years, more than 90,000 workers have fallen from heights on the job in British Columbia. Falls from high elevations result in more serious injuries than other types of industrial accidents. Often workers suffer broken bones, spinal injuries, and paralysis. The funny thing is that we're all very careful with ourselves in private life. We wear seat belts when we drive cars. We wear helmets when we ride motorcycles. We put all kinds of devices in our homes to protect our families. Everywhere we go, we're protected from serious injury by some sort of safety device. Except where we need protection most, right up there on the job site. This video is about fall protection. It's been produced for all those who've heard that it can't be done, but who really think that it should be done. Fall protection can be practical, and it can be provided economically. And more importantly, it can save lives. You'd never construct a building without a blueprint because the challenges are so complex. Fall protection problems are equally complex. But most projects begin without much thought to solving the problems. Workers are usually left to their own devices. Most of the time, that means working without fall protection. The solutions begin with planning before work commences at elevation. Each job site is different, and each solution must be crafted to the specific job site at hand. A fall protection work plan is simply a job hazard analysis. It's like a blueprint for worker safety at higher elevations. The fall protection work plan will recognize the specific fall hazards at a particular job site, provide the appropriate fall protection methods to be used, identify the assembly, maintenance, and inspection procedures of the fall protection system, and provide for the training and rescue of workers who will use the system. The first step in this process is recognizing the hazards. How much horizontal travel is required? How much vertical travel? Where are the obstructions? Other factors that should be considered are environmental conditions, like icy, slick, or wet surfaces. The Fall Protection Work Plan will look at all these issues and more, including the number of workers involved and how often the task is performed. This type of thorough analysis has to be performed before site-specific fall protection measures can be defined. Keep in mind that safety is everyone's responsibility. Employers are responsible for providing a safe workplace, including the Fall Protection Work Plan and its systems. Supervisors are responsible for training workers in the requirements of the plan. And workers are responsible to work in a safe manner. Everyone has a role in making fall protection work. During this program, we'll be looking at the three main types of fall protection. Fall restraint systems, which prevent workers from falling. Fall arrest systems, which stop a fall in progress. And work procedures, where conventional fall protection is impractical to use. When planning for the fall hazards in a job site, fall restraint methods are always preferred because they prevent a worker from falling in the first place. Fall restraint solutions are neither complicated nor expensive to implement. High activity areas should be identified and fitted with fall restraint solutions, such as permanent or temporary guardrails. Loading forest products onto rail cars is a common operation at most mills. This activity requires horizontal movement along the top of the car. It's a job that's performed regularly on a daily basis, in good weather or in bad. But it's a job that routinely exposes workers to dangerous fall hazards. Without protection, a worker could fall from the car, risking serious or fatal injury. A simple travel restriction system using a safety line will eliminate most of the risks without compromising the worker's mobility. The system protects the worker as he travels across the top of the car. We've all seen hydroelectric workers using work positioning systems. The use of a pole belt when climbing a pole restricts the worker's travel and eliminates the possibility of a fall. And all the while, the worker has two hands free to perform his job. A bucket truck provides a safe platform from which to perform work at high elevations. Elevated work platforms, suspended stagings, and scaffolding all provide a safer footing when working at heights. While temporary guardrails and other physical barriers are effective and economical ways to prevent falls, warning lines can be used to cordon off fall hazard areas.
Before we start an operation, we'll look at how we keep our workers safe, and we plan to eliminate the hazard. And the only way we can do that is to allow the worker as much freedom of movement to do his job and also be restrained. And that takes planning and pre-engineering to be able to do that.
When it's impractical to provide fall restraint, the worker's next line of protection is fall arrest, where the worker's fall is arrested by means of a body harness or safety net. There's many different types of fall arrest equipment, but they all have three elements in common: an anchorage point, a connecting means or lanyard, and a body holding device or harness. Working together, these three elements constitute a personal fall arrest system. Falling into a safety belt could cause serious internal injuries, and harnesses are the preferred choice. But not all body harnesses are equally effective. This test film shows how different harnesses react to the same weight-through-distance forces. It's important to wear the right harness properly fitted. The lanyard should be connected in line with the spine, where the shock of the fall can be distributed between the shoulders and the hips. Shock-absorbing lanyards go a long way in cushioning the force of the fall, but they can lengthen the fall as well. Choose an anchor that will let you move enough to do your job. Check out the anchor point thoroughly before trusting your life to it. The anchor point must be strong enough to bear the forces of a fall and be free of any damage. Try to stay close to the anchor point. If you move too far away from your anchor and fall, you risk swinging into objects below. This is called a swing fall hazard. The further you move horizontally from the anchor point, the greater the swing fall hazard. Lifeline systems can be vertical or horizontal. They're designed to go beyond the length limitations of a lanyard, providing both mobility and protection. Vertical lifelines with rope grabs are particularly useful when you're involved in work at heights. The rope grab is designed to lock onto the lifeline when a fall occurs. Retractable lanyards and lifelines have a locking mechanism which activates when a fall occurs, like an automotive seatbelt. These devices are designed to arrest free fall in inches and eliminate the dangerous slack that can develop using fixed-length lanyards. Safety nets are designed to provide passive fall protection under and around elevated work sites, such as bridge construction. The net is there to catch the worker after a fall.
We use fall arrest systems to enable us to safely gain access to all the high points on our equipment in order to do regular maintenance and safety inspections. We overcame workers' resistance to fall arrest systems by asking for feedback from the employees as to what they would like to see in the systems and implementing as many of those procedures as possible, thereby enabling them to work more safely and more comfortably at heights.
When it's impractical to use fall arrest or restraint devices, we need to modify our work procedures as a means of providing fall protection. Erecting scaffolds is a relatively dangerous job in terms of falling, so it's important to follow correct work procedures when putting up scaffolds. A safety monitor is a relatively new concept in fall protection, where a trained worker oversees the crew and continually advises them of fall hazards they may be exposed to.
On this job here, we've got a safety line 6.5 feet in from the outside perimeter, and the fellows that are working outside, I've got a number of hazards that the monitor has to alert them to. They're moving backwards and laterally, and they'll come to protrusions, lead stacks, vent systems, as well as turning their back to the outside edge. So the monitor has to keep them aware of those perils.
Planning and training are extremely important. The employer must try to foresee the situations that the workers might encounter. The workers must then be provided with appropriate training so that they are as experienced as possible and know the range of options available to them. Fall protection starts with planning. When you look at a particular job site, recognize the specific fall hazards and plan solutions to deal with them. This will become the blueprint for worker safety, the Fall Protection Work Plan. The solutions will include fall restraint methods, which prevent workers from falling, and fall arrest devices, which stop a fall in progress. Where these techniques are not practical, variations on work procedures should be considered and prepared for to deal with the possible fall hazards. Learn how to use the equipment correctly and maintain it carefully. In the event of a fall, have an effective rescue plan and make sure that everyone is trained properly. We've all heard that fall protection is too much of a hassle, that it gets in the way of production, or that it costs too much to implement. But the fact is that fall protection doesn't have to be expensive, and it can be used easily on the job site. Why use fall protection? There's a real simple answer. It could save your life.